Well, this is probably my last offering in this shirt for this day. Oh my heavens. Lesson 37 coming up here, using scientific notation. For whatever reason, scientific notation seems to be really scary to people, and really it's not. And you have to learn how to use scientific notation in all the sciences and all the maths. Later we'll find out why. It has to do with logarithms and making problems way, way easier, especially if we're multiplying together large numbers or dividing large or very, very small numbers. Have you ever seen either the app or the YouTube thing about the scale of the universe? You should check it out if you haven't. Just do a quick YouTube search for the scale of the universe, and it'll zoom way out and zoom way in and do it things by factors of 10. They're saying this is 10 times as big as that thing, and this thing is 10 times as big as that thing, until we get to like galaxies and the diameter of the universe or whatever it is, all the way down to like really, really tiny things. Like this is the width of wavelength of light. Okay, and they're saying like they're scales factors of each other by powers of 10. Scientists do use very large numbers and very small numbers. So in order to simplify the math behind them, and maybe even to get your brain wrapped around the size and comparative scale of these things, scientists use scientific notation. Hey, if you're talking about the distance to a star, or you're talking about the width of a flagella on something, very big and very small numbers. So let's bring it in and make it a little bit easier. Now here's a thing where we can use our calculators to help us with this, because I know that you know how to add, subtract, multiply, and divide, but keeping track of decimal places and those kinds of things can be pretty tricky. So I want to show you two things on your TI 84 that might help you with this scientific notation stuff. First of all, it would just be typing things in scientific notation. Let me show you two ways that you could do that. Let's take this number right here, 1.08 times 10 to the third. That's written in scientific notation. And the 1.08 is not very hard to do on your calculator. But what about the times 10 to the power of? Well, if you look over here on this side, you should find a 10 to the power of. So you can say times, and then you're going to go and access that 10 to the x, it's in blue, by using the blue second button. You go second, and then push that button there that says log. And then it'll access the blue part there, and then it'll type it in, and you can put in your, what was it, 3? Okay, so it makes it look kind of funny, but that's one way to do it. And then when you hit enter, it'll write that thing out the long way. Another way to write this, 1.08 times 10 to the power of, is this button right here. Well, let me show it to you. This is how you would get to it, using the second and then hitting the comma. And the thing above it says EE, which I've looked that up. I think it has to do with, came from engineering, and it has to do with exponents, okay? So you can go second and then press the comma, and up pops an E. And here, E means times 10 to the power of. So all we need to do at this point is to type into 3. You can write it like this, 1.08 E3, and you get the exact same answer, just to show you that those two things are the same. So again, they're over here on this side. You've got 10 to the power of, and you've got the double E thing, and those two things mean the same deal. So you can type a thing in scientific notation, you can figure out what the real deal is. But our usual problem is starting with 1080 and turning that into scientific notation. And the calculator can do that for you. And the way that you're going to be doing this is you're going to change the mode. You can get all these categories here, and you're going to go down on mode until you find the part that says normal, sci, and ing. And you're going to go ahead and put your cursor on, mine's right now is on normal. I'm going to go and put it on scientific, and then hit enter, and the cursor goes over to that. Now to get out of that, you're going to go second quit, and now when I type in 1080 and hit enter, it gives it to me in scientific notation. It automatically moves that decimal point and fixes the stuff for me. Now I do want you to know how to do that by hand, but I do, to double check things or to make sure you don't make mistakes, you can do that on your calculator. If you leave it in that mode, all your answers will be in scientific notation. And if you get tired of that, you can just hit that mode and make sure that it goes back. You can go back and click it to normal again, and then that won't happen anymore. But I'm going to leave mine in scientific for right now, just to be safe. So now the reason why this is the case is that basically we want it as a number that's easy to deal with, and that would be a number between 1 and 10. You can see the definition there in your book. Scientific notation is a number written as the product of two factors. The factors come in the form of A, that's your number between 1 and 10. It can be 1, it can be all the way up to 10, but not including. And then the other factor being times 10 to the power of, where n is an integer. That means it's a whole number. Okay? So that's why we're writing these things like 1.08. That's a number between 1 and 10, times 10 to the power of, and then you've got an integer. Integers can be negatives, could be positives, could be 0. Those could be integers, counting numbers and whatnot. So that's the rule. Here's A, and you got times 10 to the power of some integer n. It has to be in that type of format. So we're going to take a big number, and I'm going to add a decimal point here. And I've got to write this in a way that I express this as some number between 1 and 10 times a power of 10. And so I'm going to start moving my decimal place over this way. 1, 2, 3, 4. I'm going to plop it right here. If I put it there, it'd say 15, and that's bigger than 10. So I'm going to put it right there, and I've got the number 1.5. Okay? Then I just have to say, what did I just do? Well, doing that, I don't want to change its value, so I have to take into account all that moving that I did. And that's basically I was multiplying by 10 to move it back this way. So if you have 1.5, what would you multiply it by to get back to 150,000? You'd have to multiply it by 10 to the 5th power. And here's a quick little rule. If ever I end up moving the decimal place that way, I count how many decimal places I moved it, and I get positive whatever that number is. And if I end up moving the decimal place this way to get a number between 1 and 10, I'm basically taking 10, and I got to include it to a negative, indicating that I've just done division in order to do that. That would happen on a problem like this up here, where I have a very, very, very small number. Now here's the place where I would put that decimal point in order to make it a number between 1 and 10. And I've just moved the decimal place this way, which means to get this number back to this small number, I'd have to divide by a whole bunch of powers of 10. And counting, I had to move it 1, 2, 3, 4, 5, 6 places. So I'm going to indicate that division happens there to get it back to the original, to the negative 6th power. You remember, that means times 1 over 10 to the 6th. So we would be dividing by powers of 10 to go that direction. And you just have to think about it. If I've got a small number and I make it bigger by calling it something between 1 and 10, I have to be honest and account for that by saying that to get back to the original, I would have had to divide it. So I end up with a negative exponent there. But use this little rule as you're moving that decimal place. What do I do with the exponent? What's a positive exponent if I have to move the decimal point this way? To account for getting it back, I would have to multiply by powers of 10, and this one going this way. If I move the decimal point this way, I have to account for getting back to the original by using division or using a negative exponent. Simply stated here, they had a whole bunch of these there in the book, and we're looking at their value, right? 1.08 times 10 to the 1 is 10.8. 1.08 times 10 to the 2 is the same thing as multiplying by 100, right? Same thing as multiplying by 100. And that gives me 108. This is the same thing as multiplying by 1,000. This is multiplying by 10,000. And if you want to know what exponent goes on that, just look at how many zeros there were. There were 2 zeros, so we call it 10 to the 2. There were 3 zeros, so we call it 10 to the 3. There were 4 zeros, so we call that 10 to the 4. Well, so it's zeros, or we're saying how far did I move that decimal place. Any of those things would be equivalent expressions, putting something into scientific notation. Okay, let's take the problem of either multiplying or dividing using scientific notation. That is, you got two, in this case, really big numbers, and it's going to make an even bigger number because we're going to multiply them together. We're going to use the commutative property. That is, we're allowed to put these things in any order since everything is multiplied by everything else. You have this times this, and the parentheses mean multiply again. So the cool thing here is that this looks really messy. I can make this a huge number and this a huge number and then multiply together and get an even bigger number. But the cool thing is I can do this. I can say 4.2 times 1.3 times 10 to the 6 times 10 to the 4. Kind of group them a little bit differently. And this problem right here is not that hard, okay? And this is something you probably just end up doing on your calculator. And this part right here, since those bases are the same, this is the beauty of this kind of thing. All I've got to do is add those exponents up together. This is 10 to the 6 plus 4. So there's part of my answer right there. And then this one right here, I'm going to use my calculator. Just go 4.2 times 1.3, and it gives me 5.46. Okay? So I don't even have to make them really big. I don't have to put them out of scientific notation. I can just multiply them in scientific notation, and I'm just adding up those powers of 10 onto it. I'm basically adding how many zeros I would have, and I add it all up and I get 10 zeros. Sometimes you're going to have to adjust a little bit, but that's why it might be a good idea just to double check. I could type this exactly the same way as it is up there on the board. 1.3 10 to the 4. And I'm going to use that E button there. So there you go. You can kind of see that. And when I hit enter, it's going to give it to me in the format like that. 5.46 times 10 to the 10. That's scientific notation, right? We can do this with division as well. Let me take these two numbers. Do division. Same thing. Everything's, this is a division problem, and that's a division problem. So let's take this division problem first and just do 4.2 divided by 1.3, and I get 3.23 and a bunch of decimal places there. Blah, blah, blah. And then this part right here can be its own separate problem, and that looks familiar, or it should, because if I put this up here, this becomes times 10 to the negative 4, or times 10 to the 6 minus 4 power. That's pretty easy. It turns this division problem into a simple subtraction problem. 6 minus 4 is 2. You can do that on your calculator as well. Use the alpha x there to get a fraction bar. That's a cool shortcut. And type that in and to double check your work. That's pretty much it for scientific notation.